In 1492, Columbus infamously discovered the New World, a place familiar yet so alien to the Italian explorer. He was not the first praised as a discoverer, and he is far from the last. Like those other explorers, Columbus wasn't born better at discovering his world. Rather, he was the first to utilize new technology. A mere 5 years after the discovery of the Americas, Nicholas Copernicus would make a new discovery of his own. At the forefront of recent advancements in astronomical thinking, he looked to the skies for proof that the Earth was not the stagnant center of the universe, but rather our planet revolves around the sun, an uncommon belief for the time. His achievements drastically changed the field of astronomy in the West, and 514 years later, a star would be named in his honor, and around that star, new worlds were discovered so totally unbelievable to Columbus, Copernicus, and even many today. The 55 Cancri star system is located just 40 light years away from our own, and in that system is 55 Cancri A, or Copernicus, the star named in his honor. This star is so very impressive not for its size or energy output, but for what orbits it. 55 Cancri AB was the first planet discovered in a multiple main sequence star system, a binary star system. This means that while Cancri AB orbits its host star Copernicus, Copernicus is in turn gravitationally bound to another star. This second star, 55 Cancri b, is a small red dwarf, located on average 1,065 astronomical units from its partner, thus not contributing much energy to the planets of the system. Planets as in more were discovered, 4 more planets. In order from the star, they go 55 Cancri E, AB, C, F, and D. When coming up with more personal names, it was voted to give them the simpler titles of Janssen, Galileo, Brahe, Harriot, and Lippershey respectively, all names after men who contributed prominently to the astronomical field. I will refer to these planets as both of their respective names interchangeably throughout this video. Galileo was the first planet discovered, and is a large Jupiter-like planet that quickly rotates around its star. This type of planet is very conducive to discovery via the Doppler effect, a method of measuring a star's slight changes in radial velocity caused by, in this case, a planet's gravity. Not only was AB discovered this way, most exoplanets are, and as a result, most exoplanets are massive with short orbital periods. Despite having no way of sending a satellite to this planet to view it, much has been inferred about it. It is the second planet from its host star and is known as a hot Jupiter, a large gas giant in close proximity to its star. At around 85% the mass of our largest gas giant, it rotates around Copernicus in just 14.5 days. The heavy atmosphere and proximity to the star put the average estimated temperature at such high levels that known life could not survive. Even though the pressure of our solar system's gas giants have managed to compress their cores into solid forms, the temperature on AB is so extreme it manages to put enough energy into the core it can't solidify. Not only does the planet not have a surface, it doesn't have a clear top as its proximity to Copernicus is slowly evaporating its upper atmosphere, giving the planet no definite shape. The third planet from the star, Brahe's discovery may be even more interesting than the planet itself. When Cancri AB was discovered using the Doppler effect, it was determined that another object must be influencing Copernicus as well. Thus, the hypothetical planet 55 Cancri C was proposed. It was only officially discovered in 2004, where it was determined that the planet is another gas giant closer in mass to the smaller giants such as Neptune and Uranus, rather than Jupiter. Similar to Galileo, the planet's atmosphere is burning away, but likely at an even faster rate due to the lesser mass. Moving farther from the star, and to the fifth and final planet in the system, Lippershey is the largest planet. Just as far from Copernicus as Jupiter is from the Sun, this distance allows the gas giant to remain relatively cool, maintaining its colossal atmosphere. At 3 times the mass of Jupiter, the planet's gravitational effect is felt throughout the entire system, keeping the rest of the celestial bodies in check. This is similar to how Jupiter and Saturn manage to maintain our delicately balanced orbits. The fourth planet from the star, Harriot, is another world unlikely to harbor life. However, the planet manages to barely maintain orbit in the habitable zone of Copernicus. The gaseous planet is hostile to life as we know it, with an atmosphere consisting of gases not very convenient for life. Yet, any potential moons could support liquid surface water, a necessity for Earth life. The only known non-gaseous planet in the system Janus is a super-Earth, a planet with a mass in between that of Earth and Neptune. At just 8 times the mass of Earth, it is also the least massive of the objects known in the Cancri system. Despite this seemingly heavy mass, the planet is only 1.8 times the radius of our homeworld, making it incredibly dense. Some scientists believe the dense material making up the mantle is diamond itself, the planet even raining diamond onto its surface. What scientists at organizations like NASA are certain of is that Cancri E is a baking world. At only a little over 1/10 the proximity to Copernicus as Earth is to the Sun, molten rock flows, forming lava tubes and pools similar to those of the rivers and lakes of Earth, giving the surface a unique appearance unseen anywhere else in the galaxy, more akin to the hazy hellscape raining solid rock than the lush alien jungles that humanity hopes to find. While these are the only known planets in the 55 Cancri system, it is completely possible that more exist, at the moment unfound. It is even possible, if not likely, that moons, major or minor, orbit many of these planets. The system is without doubt a treasure trove of astronomical information for humanity, both present and in the future.